Welcome to the 16th lecture of Digital Electronics. In this lecture, we will be dealing with exclusive OR and exclusive NOR gates. So coming to the first part, that is exclusive OR gates. It is also written as XOR gate, or simply you can write it as Xor Gate. Okay. So here the specialty is that if all inputs are logic 0 or logic 1, then the output is logic 0. That means suppose if you are having a 2-input XOR gate, if I am writing a truth table, input is there, output is there. I am having 2 inputs, A and B. Output is S, 0 0 0 1 1 0 1 1. Here what is the logic? If all the inputs are logic 0, then output is logic 0, as well as when all the inputs are logic 1, then output is logic 0. For all other cases, the output is logic 1. Okay. For all other cases, for all other combination of inputs, the output is logic 1. Now if you are drawing the symbol of the XOR gate, you can draw like this: A, B, and then an OR. Okay. So we will get X is equal to A XOR B. So this is a symbol for XOR. Okay. Now if you are having 3-input XOR gate, here one more example. If you are having 3-input XOR gate, then how would it be? First you draw the truth table. In the case of truth table, have inputs first. Inputs are, we are having 3 inputs. Say A, B and C are 3 inputs. X is the output. Okay. 0 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1, then 1 1 0 1 1 1. So here what is the basic logic? If all inputs are logic 0 or if all inputs are logic 1, then the output is logic 0. That means here this is 0, then this is also 0. Okay, but here there is a difference. See here what we can see: 1 A XOR B XOR C. Here what happens? A XOR B is 1 XOR 1. 1 XOR 1 is 0. Again, what is 0 XOR 1? Now that is XOR with C. So it is what is 0 XOR 1? That is 1. Okay. So please take care of such kind of XOR gates. Okay. But actually what happens is that in the case of 3-input XOR gate, A XOR B XOR C. So 1 XOR 1. 1 XOR 1 is 0. Okay. 1 XOR 1 is 0. That is XOR with 1. So 0 XOR 1 is 1. So this definition is only applicable to 2-input XOR gate. If you are having any input XOR gate, you will have some different combinations that I will explain it afterwards. Okay. So this one, so if you are writing the combination, then 0 XOR 0 XOR 0 is 0. 0 XOR 0 is 0. Then again that 0 XOR 1 is 1. 1. 0 XOR 1. Here we get 0 XOR 1 is 1. 1 XOR 1 is 0. 1 XOR 0. 1 XOR 0 is 1. 1 XOR 0, that is again 1. 1 XOR 0, that is 1. 1 XOR 1, that is you will get 0. 1 XOR 1 is 0. 0 XOR 0 is 0. So that is how 3-input XOR gate is functioning. So here what happens is that this definition is applicable only for 2-input XOR gate. Only for 2-input XOR gate. Okay. So here what happens in the case of 3-input XOR gate, how we can represent it? Okay. So it is A, B, C. So we get H. It is equal to A XOR B XOR C. Okay. So basically the XOR operation starts from 2-input XOR gate. Now coming into okay, so that is H is equal to A XOR B. So now coming into A, okay, now can you make XOR gate as an inverter? That's the question. Can you make XOR gate as an inverter? Okay, that is one thing I have forgot to mention. Before going into XOR gate, see here what we can say. This is basically you can use it as a inequality detector. You can use it as a inequality detector or anti-coincidence detector. That is what is inequality 0 1 1 1 0 1. Whereas for XOR gate we can have 1 XOR 1, that is considered as an inequality to 1. So here what we can say is that if there is any inequality in the case of input, you can determine it using XOR gates. Okay, so that is so that exclusive OR gates or XOR gate is also known as inequality detector or anti-coincidence detector. Now coming into the part which I had. Now can you use this XOR gate as an inverter? Now see, while discussing about the gray code, I have already explained about the XOR forms. That means here what you can say, from this 2-input XOR gate, it is clear that 0 XOR 0 XOR 0 is 0. Again 0 XOR 1 is 1. 1 XOR 0 is 1. 1 XOR 1 is 0. Okay. So how to make this as an inverter? How to make this as an inverter? Now see, suppose I am taking one input here. Okay. If A is 0 and other input is 1, you will get the output as 1. Again, if A is 1, okay, exclusive day, that means okay. Now that means how you can make it as an inverter? See, you should use it in two forms. Okay. So you are having A, say Y, you will get X. Okay. So you should get X is equal to A bar. Okay, that is the question. That means here, so here actually what is X? X is equal to A XOR Y. So when we can get X is equal to A bar? Okay, see, when input is 0, the output should be Y should be equal to 1. That is the first case. Okay, when A is equal to 0, then Y is equal to 1. In that case, that XOR gate can act as an inverter. Again, if A is 0, then Y should be 1. That is the first case. Then if Y is 1, you can say that X is the invert of A. That is the first case. Second case is that, second case what I can say is that this is X, so this is Y. When A is 1, then Y is 0. Then what we can say? Here is also it is also not inverting. Again, if A is 1 and Y is equal to 1, if A is 1 and Y is equal to 1, what happens? What is 1 XOR 1? 1 XOR 1 you will get it as 0. What is 0 XOR 1? 0 XOR 1 is 1. That means if one of the inputs is made to 1, if one of the inputs of 2-input XOR gate is made to 1, is made to logic 1, then it can act as inverter. That means in the first case what will you get? X is equal to A and Y. When A is equal to 0, you can make Y, and Y is equal to 1, you can take X is equal to 1. Again, when I am making A is equal to 1, Y is remaining as 1 itself, you will get what is here, what is says. This is 1 XOR 1. 1 XOR 1 is 0. Here what will you get? This is 0 XOR 1. So here we can say that this 1 is the complement of this 0. Again, here what we can say, this 0 is the complement of this 1. Okay, that is how you can take XOR as an inverter. That means X is equal to XOR Y, and Y should always remain as 1. Okay, that is how XOR gate is acting as an inverter circuit. Okay, now coming into some properties of XOR gate. Properties of XOR gate. First property is A XOR 1 is A bar. That you have already proved. That means when A is equal to 1, it is 1 XOR 1. 1 XOR 1 is 0. When A is equal to 0, 0 XOR 1. 0 XOR 1 is 1. So you can say that this is the complement of this. Okay. Second one is A XOR 0. A XOR 0 is A itself. So that means if I am having 1 XOR 0, 1 XOR 0 is 1. Again, 0 XOR 0 is 0. That means this 1 is directly transferred here. This one is this here first. The complement of first column is here. This is the first column itself. Okay. That is the second property of XOR. Third property is A XOR A. A XOR A is 0. That means you will get 0 XOR 0. 0 XOR 0 is 0. Similarly, 1 XOR 1 is also 0. I proved that property. Then fourth property is A XOR A bar is equal to 1. That means if I am having A as 1, so I am having, this is first property, second property, third property, fourth property. If I am having A as 1, XOR A bar is 0. What is 1 XOR 0? 1 XOR 0 is 1. Similarly, if I am having A as 0 and A bar, then you will get A bar as 1. So what is 0 XOR 1? That is 1. So it is A XOR A bar, that is equal to 1. So coming to fifth property. Fifth property is AB XOR AC is equal to A into B XOR C. This is basically the associative property. Associative property of XOR. That the proof of this will be dealt when we are dealing with the proof of Boolean algebra. And the last property, sixth one, and they have is if A XOR B is equal to C, if A XOR B is equal to C, then we can say that A XOR C. Okay, then you can say that A XOR C is equal to A XOR C is equal to B XOR C is equal to B XOR C. Then that is equal to A. That is equal to A. And again we can say that if that is again, if A XOR B is equal to C, then we can say that A XOR B XOR C is equal to 0. Okay. So try to prove this yourself. Okay. Or I will do the proof while we are dealing with the Boolean algebra. Okay. This we can prove using Boolean algebra. So in the coming lectures we will be having the algebra and its proof. So after doing that proof, we will be dealing with this proof. So that is the properties of XOR. Okay. Hope you have understood the concept of exclusive OR gate. So you have till now we have discussed about 2-input XOR gate, and as well as 3-input XOR gate. Okay, and 2-input XOR gate is also known as inequality detector, or we can say it as anti-coincidence detector. Now coming into XNOR gate or exclusive NOR gate. Exclusive NOR gate. Okay. It is also known as coincidence detector or equality detector. Coincidence detector or equality detector. Now if you are drawing the basic symbol of the logic gate, it will be XOR with a NOT at the end. So it is A, B, here you will get X. X you can represent it as A XOR B, the whole bar, or we can represent it like this, A dot with the circle B. So this is A XNOR B. Now if you are writing the truth table, I am having 2 input. So inputs are inputs, outputs. Inputs are A and B. Output is X. So 0 0 0 1 1 0 1 1. So here what happens? Here this is 0 and this is 0, and here you will get 1 and 1. So here what happens is that this is if 2 inputs are 0, the output is 1, whereas if 2 inputs are 1, the output is also 1. Okay, so this is exact inverse, it's a exact complement operation of XOR gate. Now if I am dealing with this one, if I am dealing with 3-input XNOR, 3-input XNOR gate, how will it be? We can take like inputs. Inputs are, we get 3 inputs, A, B and C. That is 0 0 1 0 1 0 0 1 1 1 0 0 0 1 0 1 1 1 0 and 1 1 1. So what is X output? Output becomes X, that is equal to A XNOR B XNOR C. Okay. What is one more is that is 0 0 0. I have forgot this again. What is 0 XNOR 0? 0 XNOR 0 is 1. That 1 XNOR 0. 1 XNOR 0 is again 0. 0 0 1. 0 XNOR 0 is 1. 1 XNOR 0. Or in a simple way you can write it as A XOR B XOR C, the whole bar. This is a very simple operation. Then I will do with that. So it is 0 XOR 0 is 0, and 0 XOR 1 is 1. 1 bar. 1 bar is again coming into 0. So here what will you get? 0 XOR 0. 0 XOR 0 is 0. 0 XOR 0 is 0, and 0 bar is 1. Sorry. So you will get 1 1 1. So you will get value as 1 only. Yeah. Next one is A XOR 0 XOR 0. 0 XOR 0 is 0. Then 0 XOR 1. That 0 into 0 XOR 1 is 1. 1 bar is 0. 0 XOR 1 is 1. 1 XOR 0 is 0. 0 whole bar is 1. 0 XOR 1. 0 XOR 1 is 1. 1 XOR 1. 1 XOR 1 is 0. 0 bar is 1. 1 XOR 0 is 1. That 1 XOR 0. 1 XOR 0 is 1. 1 bar is 0. Again. 1 XOR 0. 1 XOR 0 is 1. That 1 XOR 1. 1 XOR 1 is 0. 0 bar is 1. 1 1 0. 1 XOR 1. 1 XOR 1 is 0. Then 0 XOR 0 is 0. Again that 0 bar is 1. 1 XOR 1 is 1 XOR 1 is 0. 1 XOR 1 is 0. That 0 XOR 1 is 1. 1 bar is 0. That means if I am taking the example of this 101, 101, 1 XOR 0, 1 XOR 0 is 1. Again, that 1 is XORed with 1. 1 XOR 1 becomes 0. Need to give the bar of that answer. So it is 0 bar, that is 1. So I am taking 111. 1 XOR 1. 1 XOR 1 is 0. That 0 into last one. That is that 0 XOR 1. What is it? 1. And take the bar of it. That is 0. You will get the answer. Hope I think you have got how an exclusive NOR operation works. Now, can you make this XNOR gate as an inverter one? XNOR gate as inverter. Okay. So I am having a XNOR gate. Okay. So we get A. Okay. Suppose I am giving 0 here. I am giving 0 as input. So I will get S is equal to A XNOR 0. A XNOR 0. So let me check what happens here. So here what happens is that I am having input. Input is A and the next input say X. Sorry, no, not X. I am taking as Y. Y is 0. A can be 0 and 1. Y is 0, 0. So what is the output? X. Okay. So 0 XOR 0. 0 XOR 0 is 0. And you have to take the bar of it. What is it? The answer is 1. So we can, now again, what is 1 XOR 0? 1 XOR 0 is 1. Take the bar of it. Therefore the answer is 0. Therefore what we can say is that the output column is the complement of A. That means when A is equal to 0, X is equal to 1, and when A is equal to 1, X is equal to 0, provided Y is equal to 0. Therefore we can say that if one of the input is 0, we can say it as a complement. That means this is the way in which the XNOR gate can act as an inverter. Okay. Hope you have understood the concept. Okay. So that is all about an introduction to XNOR gate. Okay. So in this lecture what I have dealt with is what is exclusive OR gate or inequality detector or anti-coincidence detector. We have done with XOR laws, and we have realized an XOR circuit, XOR gate. Then 3-input XOR gate also is explained. Then how this XOR gate can act as an inverter, that is dealt with. That means if one of the input is remaining as 1, then always this XOR gate can act as inverter. Similarly, properties of XOR. Then we have dealt with XNOR gate and how this XNOR gate can act as an inverter or NOT gate. So in the next lecture we will be dealing with how this these gates, that is AND or NOT, XOR, XNOR and NAND and NOR deals with signals. And we will start with some Boolean algebra also, if possible, in the next lecture. Okay. So initially we will deal with how to form an output waveform when some input is given to a gate. So that we will deal with 1 or 2 1 or 3 or 4 examples. Okay. And with that I am ending with the portion of this gate. Okay. Now how to realize all other gates using this NAND gate and NOR gate, that will be dealt after that. Okay. So thank you and see you in the next lecture.